number 1, which is in preparation for real quiz number 1 tomorrow. It's going to look an awful lot like this, right? If you understand this, I'm not saying if you remember the answers to this or you remember exactly how to do question number 1 or question number 2, whatever, but if you understand all of these questions, you will be absolutely fine on tomorrow's quiz. I promise you that, okay? Question number 1 says, identify each of the following as a vector or a scalar. Is displacement a vector or a scalar? Yeah, that's a vector. How did we define displacement? Oh, yeah, it has both direction and magnitude because it's a vector, yes. But how did we define the term displacement? Yeah, Michael? Or Martin, I mean, sorry. Yeah, it's a change of position, right? The position is where something is relative to something else, and the displacement is the change in where something is relative to something else. Well, if displacement is a vector, and it's a change in position, then position would be a vector as well, right? What about distance? Yeah, it's just how far something's traveled, and it's going to be a scalar. The distance between here and, we said the other day, downtown Calgary is 39 kilometers. We don't say 39 kilometers to the north. We could. That wouldn't be distance anymore, right? That would be the displacement that you had as you traveled from here to downtown Calgary. Good. Okay, let's look at number 2 now. It says a man walks 100 meters to the north, then turns around and walks 30 meters to the south. What's the man's total distance traveled, and what's the man's total displacement? We got a north here and we have a south, so we got to watch out for that, right? We got to watch out for that. That is, if we're dealing with vectors. If we're dealing with scalars, it doesn't matter. In question number 1, we're looking for the distance traveled. The distance traveled, and you just told me a minute ago the distance was a scalar. So I don't need to pay attention to the direction, at least not yet. There's 2 ways to find this. 2 ways to find distance or displacement. If we have displacements given to me already, which is what we have here, then we're going to add them. If we have positions, then we're going to subtract them. These are distances, or displacements, I should say, so we're going to add them together. The total distance is going to be the first distance plus the second distance. We're going to say it's 100 meters to the north. Well, no, we're not going to say 100 meters to the north. We're going to say just 100 meters, yes, plus 30 meters, which is going to give me 130 meters. So my answer for this one is 130 meters. Number, or 2B, the displacement. Again, we want to find total displacement. We're going to add displacements, right? So we've got displacement number 1 plus displacement number 2. This time we're going to say 100 meters to the north. By the way, let's define north as positive so we can use the signs. 100 meters to the north, positive 100 plus, what's this one going to be? Negative 30 meters, right? We add those together and we get 70 meters. What does the positive mean right there for the 70 meters? Yep. It means it's to the north, right? We define north as positive. Positive means to the north. What does the positive mean right there for the 130? Trick question, right? It means nothing, right? Because it's a scalar. Positive, negative doesn't really matter because it doesn't mean anything. How come these 2 numbers are different? We often find that distance and displacement are the same number, but how come they're different in this case? Yeah, because we changed direction, right? If we continued walking to the north, it'd be 130 in both cases, or to the south in both cases, it would be 130 for A and B. But if we change direction, north then south, then distance and displacement will be 2 different numbers. Okay, 3. 7-Eleven is a kilometer south of HTA. The dog stadium is 2.5 kilometers south of HTA, and McDonald's is 4 kilometers south of HTA. Mr. Dickie runs from 7-Eleven to McDonald's, then back to the dog stadium. What's his distance traveled and what's his displacement? This is one of those questions where I think it can be useful to draw the little map. It's not critical, it's not necessarily at least, that you draw the map. But if you're having any trouble with this at all, it might be useful to draw that map. Displacement, not so bad, right? Displacement, we don't usually really need the map for displacement, but for distance it can be helpful. Let's do displacement first, actually. What do we have given to us here? Are these positions or are these displacements already? Yeah, these are positions. These are where I am at different times, right? I'm at 7-Eleven, then I'm at McDonald's, right? And then I'm at the dog stadium. What's my displacement? So if we're looking for the displacement given positions, we're going to say final minus initial position. Wait a second, I have 3 positions here, right? I'm at 7-Eleven, and then I'm at McDonald's, and then I'm at the dog stadium. Do I have to include 3 different positions here in my little equation? Like D3 minus D2 minus D1 or something like that? No. It doesn't matter how I get from the initial to the final place, right? Hey, remember the track, right? It doesn't matter how you get from the start line back to the start line. Your displacement in that case is 0. So here it doesn't matter how we get from 7-Eleven to the dog stadium, my displacement will be the same. It's simply final minus initial position. My final position here is the dog stadium, right? And the dog stadium is 2.5 kilometers south of HTA. So that means my final position will be negative 2.5 kilometers. Does that make sense? Does that make sense? Did anybody define south as positive? Is that okay? Yes, it is. In fact, it might actually be. Yeah, I'm gonna keep it as negative actually, but it's okay to make it positive as long as you specify that, right? So my final position is negative 2.5 kilometers south of HTA. I've used HTA as my reference point for my final position, so I need to use HTA as my reference point for my initial position as well. What would be my initial position? 7-Eleven, right? 7-Eleven is 1 kilometer south, right? Is that right? Negative 2.5 kilometers because that's where the dog stadium is relative to HTA. 7-Eleven is negative 1 kilometer south of HTA. Negative 2.5, negative 1. What am I missing here? Yeah. Yes. It's negative 2.5 subtract negative 1. It's final minus initial. It's not just, oh, make sure there's a negative in between there because it's subtracting. It's final minus initial. If the initial is a negative, then a minus is different, right? It's essentially like a plus, right? So we're going to say negative 2.5 plus 1, which is negative 1.5 kilometers here. Which makes some sense, right? If I start out at 7-Eleven and I go to the dog stadium, then I'm going to have traveled to the south, negative 1.5 to the south. Okay. Sorry, not negative 1.5 to the south. Negative 1.5 or 1.5 to the south. Or if you defined south as positive, you would have gotten positive 1.5 there, right? Okay, what about the distance? This is the one where I think that it's useful to draw the little map here. Here's HTA. Here's 7-Eleven. 7-Eleven is 1 kilometer south of HTA. The dog stadium. The dog stadium was 2.5 kilometers south of HTA. And then McDonald's was 4 kilometers, I think I'd said. Right? How many of you guys drew a map like this? Or kind of like this. It might look different, but more or less. Okay, good. So what did I do? I started at, I think I started at 7-Eleven, didn't I? Started at 7-Eleven, then to McDonald's, then back to the dog stadium. So I went from 7-Eleven to McDonald's, and then back to the dog stadium. My distance traveled would be what? Well, from 7-Eleven to McDonald's is how far? 3 kilometers? And then McDonald's to the dog stadium would be what? Looks like 1.5 kilometers. What's my distance traveled? My distance traveled would be 4.5 kilometers. Positive? Negative? Well, it actually does matter. It should just be positive, right? Because it's a scalar. But the positive doesn't mean anything, right? We just don't want to put a negative there ever because, well, if we get a negative there, then it means we've done something wrong throughout the problem in including negatives, which we don't want to do here. We're finding the distance. Good. Okay, how many people got 100 on that fake little quiz? Good. Good. Okay, 100 on tomorrow's quiz. Listen, right now, I got to be honest with you. It's a little disappointing. When I looked at Power School last night, our class average is 0. I'm hoping to improve that tomorrow. I'm thinking that we'll improve that tomorrow. I'd rather it be closer to 100 than 0. If you make a mistake, that's okay. It's okay to make a mistake, but You want to get away from that cross average of 0, right?